in general will be devoted to vibration problem. And the presentations will be given by two professors, one professor from India and the second professor from Germany. Sorry, but I will not list your names because I'm sure by the presentation you will just introduce yourself by the slides and by talking. And now I invite you to participate in the seminar, but before we start, let's agree the frame. That means my question to the presenters: how you prefer to answer the question? After finishing your talk, or
yes, that will be great.
After finishing, that will be better.
Okay, that's now just the message to all participants. If you have any questions, please keep in mind and ask the presenters after finishing the presentation. And who will be the first presenter?
I will start.
Please,
okay.
Please.
Yes.
Thank you very much.
Yes, the virtual floor is taken by Professor.
Professor Arkan.
Yes, please start.
I hope that you can see my screen now. Is it possible?
Yes.
Perfect. Perfect. Also, good morning and good afternoon by me, dear ladies and gentlemen, dear Vice President Teresa. Thank you very much for this great possibility to give a talk with my colleagues from India about our research work. I am very happy about it, and also thank you very much to Heritage Network to organize this event. IIT Dhanbad and we collaborate each other since already more than 3 years, including PhDs, and we will publish a work together very soon. And I think that this collaboration will be more and more stronger. And today I would like to talk, as you know, that strongly on our subject, vibration monitoring and diagnostics and whole body vibrations. This is the topic of today's talk, and some research investigations which I will explain today were conducted within the excellence cluster SETI, and to find solution for the existing challenges, it is necessary to conduct multidisciplinary research. And today's topics include also different aspects, not only sensors, which I will explain, signal processing or modeling, but also telecommunication, security, human-related subjects are very important. Therefore, we try to combine this kind of research in this excellence cluster. If I start with a short content of my presentation, I will start with a short introduction. Then I will talk about vibration monitoring, challenges, sensors, signal processing, analysis and modeling, and pattern recognition. And then I will continue it with whole body vibration perception. And then I will conclude and give the talk my Indian colleagues. As I already said, I start with the first points, introduction and vibration monitoring. And here we see some products, some structures. These are the daily life products, daily life structures, and most of them, most of these products generate some vibrations and at the same time sound, and this plays in daily life very strong role on their perception and also in the interaction with these devices. Not only, of course, products, also structures starts to vibrate and generate some sounds. Therefore, it is very important to understand the vibrational behavior. For it, we use different physical measurement methodologies or simulation methodologies to understand vibration behavior of this kind of products. It means that there are strong work on the physical side to understand this vibrational behavior. And after that, of course, we have some designed vibrations, and these vibrations can give us different information related to the health of the product, quality, of the product or process, and also information about the process. And these kind of informations are important to use them and perceive them as a good or bad product. And therefore it plays strong role to understand how we can understand their vibrational behavior and the related information. And in the production or manufacturing, it plays strong role because in that case, of course, we have a lot of different machines and structures. And in that case, vibration monitoring gains more and more importance, not only for the manufacturing and production at smart fabrics, but also, of course, as I already explained, the daily life applications. And using vibration monitoring and diagnostics, it is possible to increase the productivity, to ensure the high quality production, and to inform about the operational steps. For example, in these pictures, we see some blades, and we can understand before they will be destroyed and notice the vibrational behavior, and then we can give some measures related to it. Of course, in classical way, for example, in fabrics, there are mostly talented and experienced plant and maintenance engineers. They can feel in some cases there will be some problems with these machines or electric motors, for example, in this example, and take some measures. But of course, in the future, we would like to automate it and make much more sophisticated smart systems. And therefore, we have different challenges, what I would like to talk in my presentation. And I took as example, for example, electric motors in that case, and also washing machines. If we take into account, for example, electric motors, we have more than 400 different vibration patterns which caused about different operational states, but also failure or information. And depending of them, we can decide which kind of measures are important, and we can give also design decisions. And as I already listed here, there are different descriptions of them. And for us, very important point is to understand, okay, which physical reason is behind of it, and is it good or is it bad? And we would like to give this information to the customer of these products, or at the factory to the maintenance engineers, or we would like to skip them and reduce them. As I already said, that I would like to talk about different challenges regarding vibration monitoring and failure. And in that case, I will start with the sensors. The development of and integration of low weight, small size, low cost sensors to the products or to the structures at the manufacturing line is very important point. And in that case, of course, we try to develop, in most cases, very small, low weight, low-cost sensors. In that case, of course, MEMS technologies deliver us very nice opportunities. But at the same time, if we take into account, of course, we need mostly flexible sensors. And if we can print them, it can increase our availabilities and application of several sensors at one product. Therefore, very important research topic in our area is the printed flexible sensors. And in that case, I would like to also introduce that my colleague at my chair, Junior Professor Anidya Nak, also who is working at Excellence Cluster SETI, develop different technologies for printed flexible sensors. Also at my chair, we try to develop different technologies based on piezoelectric, dielectric elastomer sensors, and also nanocomposite based or graphene based printable flexible sensors. And in that domain, there's a strong interest to develop them for the vibration monitoring. From the other side, of course, we know all of us has some smartphones, and they have very cheap cameras, very low quality cameras. But if we check the pictures of these cameras, we notice that the quality is mostly higher and higher, and it will be higher, although they are very cheap and very low quality cameras. And the reason behind of it is the signal processing. It means that mostly the trend is in that domain to make smart signal processing to increase the quality of the data which we have, also for vibration. And therefore we try at our chair to develop different analysis methodologies, signal processing technologies to give correct decisions. For example, in this picture, we see similar, different kind of vibrations and sounds. And take, in this case, this is Fourier analysis and Campbell diagrams of them. But although it is the same signal as we see above and below, depending of the FFT length, you can see very different results. And depending of this result, of course, the decision can be very different. It means that the correct and intelligent signal processing and analysis is very important topic in this point. And using it for different kind of vibrations of these products gains more and more importance. And as I already said that in most cases, it is very important to get also the feeling of the quality, because in some cases the vibration can give us a feeling that, okay, this is a high quality product or low quality product, or it can give us information about forecasting for failure and also, of course, interaction for the user. And in most cases, of course, depending of the different characteristics, depending of the different aspects of the signal, we should decide which signal properties should be used for the diagnostics, for the quality measurement, and so on. And in that case, of course, temporal aspects, but also frequency spectral aspects play strong role for vibration, but at the same domain also for sound, and we try to adapt them depending of the, of course, problem. And this is not only for example, electric motors, also for washing machines, interesting, also for manufacturing, but also for medical applications, for example, surgery robotics. And in the excellence cluster with Professor Stefanie Speidel and other professors, we try to understand how we can adapt it for such kind of robotic applications. And in that case, particularly vibrations give in some cases to the operators very useful information. It means that in that case, vibrations or sounds can be used to increase the quality of the surgery operation. But in some cases, we should reduce them, and we should observe that the operational robot functions properly. And depending on these decisions, we can give, of course, measures. And taking into account these issues, of course, automatization is a very important point. And therefore, we try to develop some algorithms based on artificial intelligence or machine learning to give data-based actually decisions. And for it, of course, in most cases, we need a lot of data, which causes, in most cases, big problem, because most of the, for example, companies, manufacturers of these machines don't want to install cloud solutions and use artificial intelligence, because in that case, of course, this data can be used by university or by other companies, and therefore they try to find solution only closed domain. And in that case also security plays strong role, databases, and depending of industry 4.0, we try to adapt different solutions. And in that case, of course, there are different ideas for machine learning, unsupervised or supervised, and multi-channel solutions play strong role. As I already said that in the second part, in the last part of my talk, I would like to talk a little bit about the perception of product vibrations, whole body vibrations, development of models, because as I already introduced, that we should analyze the vibration signals, and in most cases, taking into account the persons, the human who uses these machines, and if they perceive these vibrations or not, plays strong role. And at the same time, for the quality perception, it is very important to conduct such kind of research. Therefore, we try to adapt to both directions. And at the same time, also with IIT done, but we try to develop some ideas regarding, for example, annoyance caused by such kind of whole body vibrations, how we can describe it, how we can measure it. And in that case, we have long experience with psychoacoustics. In psychoacoustics, there are different actually analysis modeling algorithms based on loudness perception, sharpness perception, and so on. And for the vibrations, of course, in most cases, we should take into account the properties of the body in the physical side, but at the same time, perceptual aspects play a strong role. Therefore, several PhD students in my chair conduct research to understand the perceptual aspects of the vibrations, whole body or arm vibrations, and depending on them, describe models and make analysis algorithms. And in that case, depending of the frequency, depending of the temporal aspects, change our perception, and depending of them, also we should adapt the models. And in that case, of course, physiological aspects play strong role, because mechanoreceptors are responsible for the whole body vibration or hand or arm vibration perception. But at the same time, there are different kind of masking effects. For example, low frequencies masks the high frequencies, similar to the MP3. We don't perceive some signal parts, and this plays also very important role for the modeling and similar kind of issues. And using these models, we try to develop also design algorithms, for example, for annoyance, which will be perceived if we drive with a car or with a earth moving machines. And depending on these algorithms, we give also design decisions. And in that domain, we use some laboratories. Unfortunately, because of the corona situation, I will not visit the laboratory, but I will show a video to introduce. In this laboratory, we conduct several whole body vibration perception experiments. And using the platform which you can see in this picture, this is a hydraulic platform, which gives us the possibility, high amount of movement to realize, for example, from earth moving machines, but also from the cars or different kind of vehicles. But at the same time, using electrodynamic shakers, we have possibility to go to the higher frequencies. But in this laboratory, we don't only conduct vibration experiments, also for auditory experiments. Therefore, we have more than 464 loudspeakers. And I would like to show this video to introduce this laboratory. My student actually have conducted some research. I hope that I can show it shortly.
Oh, we cannot hear the sound there again.
Okay, possibly one moment. I should click also the sound. Exactly. Thank you very much for the feedback. I hope that this time.
In our multimodal measurement laboratory, which I'm going to show you now. So it consists of optical reproduction system in the form of a projector, and of course we also need acoustic reproduction, and for this we have a wave field synthesis system. It consists of 464 loudspeakers that are everywhere around the room, And with these loudspeakers, we can generate virtual sound sources at any point in the room, just like they would appear in a real environment. And of course, we also have our vibration reproduction system, consists of an electrodynamic shaker below the seat. And also we have a hydraulic motion platform that has a motion space of plus minus 300 millimeters. And with the motion platform, we can produce a peak acceleration of 1g. So if we would operate all the three systems simultaneously, this is what such an experience would feel like.
Unfortunately, sound recording is not so good, but video recording is good. I hope that it was possible to get a feeling, but of course, I invite all of you to visit us. We are not very far away from Poland and also from India. I hope very much that soon it will be possible to visit each other and show it in real life experiments. I hope that now you can see my slides. And using also this laboratory, we conduct also whole body vibration design experiments, because we can generate also vehicle dynamics, and depending of this information and using also sound, we try to generate, for example, not only unpleasant or pleasant vibrations, but also sporty and different kind of vibrations. As I already said that I would like to finish my talk because, of course, I would like to give also the word to my Indian colleagues, but I hope very much that maybe in summer it will be good possibility to visit each other, and I would like to invite you to Dresden and not only see our laboratory, also see our opera.
Sure, it is.
Thank you very much for your attention.
Very excellent presentation, sir.
Thank you for a very interesting talk. And now the presentation is open for discussion, questions. That please, I suggest that just you will start. I think that will be, who is the first asking the question, please. I do not see. Okay, please. Yeah.
Professor Arkan, can we also implement those things for flight simulators, not only for the automobile?
Yes, it is possible to integrate it, because the possibilities are very strong in the physical domain. It should function. And we have also a very nice idea to control or monitor the welding processes with Professor Somnath. I think this is also another nice, interesting point.
Thank you. Thank you. From my side, one question, sir. Actually, you are what will be the approximate cost of the tender setup facility?
Do you mean with custom?
The price, the cost of the yes.
Price of this system. All laboratory cost was about 2.5 million euros.
Euro.
It is very expensive, but at the same time, what I can say that we try to develop with the manufacturers the motion platform, which generates very low artifacts, because for research it is very important not to have harmonics. For example, if we generate some frequencies, in some cases in hydraulic systems it is possible to get some harmonics, and we try to reduce them using different principles. But also there are mufflers depending of the sound generation of the system. This caused a strong amount of costs, but at the same time, of course, it is possible to make it in basic domain, and I can imagine that this can be a cheap solution.
Very nice. Thank
Yes.
you. Thank you.
Yeah, and Professor Sagar, please, the question.
Yeah. Hello, Professor. That was a very nice presentation.
Thank you.
I am a PhD student from Materials Department, IIT Bombay. I am also working with vibration monitoring, like using triboelectric devices. So my question is regarding what type of sensors are you developing? Are you only using the commercial accelerometer-based sensors for your experiments, or are you also developing specific vibration sensors at your laboratory?
Mostly we try to adapt different sensor technologies, but at the same time, at our laboratory, as I already introduced, that graphene-based and also laser cutting-based electrode development is a very important topic. We have different cooperations with the sensor producers in Dresden and adapt their piezoelectric type technologies to our applications. And as I already said, that mostly based on the electric elastomer and also graphene-based technologies.
Thank you, Professor.
Okay, any other question?
There is a question in the chat.
Okay, let's us see in the chat. Yes, okay. Thank you for your wonderful presentation. I am doing my research on electric motors. This field is completely new to me. Can you please suggest me how to start my study on vibrations of motors or a good reference?
I can send you good references. Please send me please your email address, and I will send you some suggestions.
Okay, that I hope that the question, the person who was asking perceived the response that please send the message to Professor Erkan and you will get the advice. Any other question? There are so many participants that I cannot see the whole list to see the raised hands, that if I am not noticing, please just talk. But I do not see that. Maybe I will ask that at our university, the faculty who is doing the vibration study is Faculty of Transportation, that I am Faculty for Aeronautics and Applied Mechanics. I sent a message about the seminar. However, the problem is that still there are the students' classes, and this is by the end of the exam session. But I saw that they are doing many diploma works and the other works that it is, that what I am saying, he was telling about the visiting by Polish group or visiting
Exactly.
Poland, that I saw the common points, because testing the vibration testing is very important topic. Even I remember, because even in my faculty, aeronautics, that my people were testing the vibrations. They developed by themselves the testing stand, a bit similar like yours, however simpler, because that was years ago. And they were doing the tests, the human, how the human behaves. And also in Poland, we have the big government center of occupational biomechanics. And I'm sure they do such a test. That again, this is the common point. But my question is very simple, quite trivial, because it seems that you are testing the human being. Do you need the permission? That means because this is the biological experiment. My question is, if doing such a research for a projects and so on, that can you tell a few words about the formalities? It is easy, not easy, who is used, who is involved in the tests, the staff, or maybe the persons who are really affected to the vibrations? Just the comment on this issue, please.
Thank you very much. This is a very important topic. Exactly. We need ethical approval that we can conduct this project, and this is not so easy, what our experience says, although, of course, we conduct since several years, therefore there is a standard procedure at the university, but mostly such kind of ethical discussions are related to the medical aspects, for example, vaccine or medicaments, and they don't know very much about whole body vibrations or sound exposure and so on. And therefore, we always should introduce also the levels which can be dangerous for human. And we should show that our total exposure is under these levels to get a approval. And in most cases, there is no big problem to get it, but it takes, of course, some time because of the information exchange. But what I know that also I give supervision to the European Union Commission related artificial intelligence-based systems. And in this topic, exactly, it is very difficult to define ethical issues because the systems behave not always as expected, and depending of the user and the reactions, the reaction of the system can change, and therefore this plays strong role for this kind of research. And during the preparation of slides, I thought also the cooperation with you, because I know also in robotics you have very nice actually research and research facilities, and also other topics, and Warsaw and Dresden are very near to each other and very nice city also to visit. I will visit you, and please come to my lab.
You are very welcome, and maybe in the future it will come with some common projects. We are very interested in cooperation, I should say. But if I may, I have one more question. But just finishing, we can arrange also the cooperation with the Institute of Occupational Mechanics, that we can be involved, and also the big institute with very good equipment that we are interested. Okay, but the last question from my side. You said about using a neural network for the processing the data. And as we know well, the neural networks can act very, very nicely, but however, we are never sure if they always will be reliable. That my question is, if using the neural network, are you adding some safety mechanism just in case something will happen, that the neural network will produce the wrong output?
This is necessary. You are absolutely right. The main problem what we have is that the amount of data what we use for the training is very limited in comparison to much more commercial systems, as for example Google or similar kind of companies do. Therefore, we should always be very careful usage of this technology, and therefore, we try to define also metrics to see that which kind of input causes which kind of outputs, because at the end, of course, it is a black box, and it's a dangerous black box. And to understand this black box, we try to conduct several input and output research to understand that how react the system, and at the same time to define, depending of course, answer of the ANN, which reactions will be done. And in that case, we define some physical limitations. Otherwise, it can be exactly dangerous.
Okay, thank you. Any other questions?
Maybe we can move to the next part of the webinar, and if there are some questions left, they can be kept for the end.
Yes, sure. I do not see any questions. Anyway, that please, now the floor is in the hands of our Indian colleagues, and who will be the first? Please start. And switch on the microphone, please.
Right.
Okay.
Good afternoon, everybody. I will just give a short presentation on the vibration monitoring of a big instrument. There is a dinosaurial equipment and very specially relevant for our area of competence. And then Professor Samidas will discuss about the whole body diagnostic. But now I will do for vibration analysis for a little different aspects in terms of the operation. And this is relevant to, so go to the next slide, surface miner. This is a very, very big machines. Germany is making such machines, and Poland is also known for these very big dinosaurial fabrication of those machines. So the left part is the surface miner, and why the picture is there, because cutting drums are shown. The bottom part is shown, the cutting drum, and the right part is the LNT surface miner. And this KSM means Kanswal, where LNT, while Germany is collaborating with us to have a steel plant at Rourkela, they have opened a factory for fabrication, and that is known, that is Kanswal. So Kanswal surface miners, KSM, and 404, this 4 meter is the drum. So the right part, it is put into some part of Orissa, and it is doing huge amount of productivity, maybe 800 to 1,000 tons per hour. It can dig out, and that kind of mining it can do mainly in the coal area. Next. And the center forward of this instrument is the cutting drum along with the cutting picks. So why vibration is important? Because the geology and all those things, the surfaces are not in control. If you go for manufacturing, where my area is there, where the surfaces and their behavior pattern is under control and they have the isotropic properties. But the problem with the geological surfaces, when people start mining, the coal and those seams are not perfectly horizontal. So apart from coal, the sandstone, the shells, all those things are coming with a different universal compressive strength, and vibration monitoring, through which we should know what is the material, and according to that we can control the rotations of these very big things. If it is not done, the problem is that huge amount of wear and tear will take place in the cutting picks. Next. So one can see the rotating drum with the different configuration of the picks. They are just going through that surfaces and taking out of those holes another part of it, and that is sorry for that. And that is the main operations, and the pick lacing also has a very big role to play, and it is rotating within some few meters per minute, and according to that they will go for this cutting form. Next. And this is the thing that apart from this vibration monitoring, what we have to do, we have to know what are the layers are there in the geological surfaces, and this man is experimenting with the skimmed hammer to know from the vibrations or pulsations, so that what can be the probable uniaxial compressive strength, because to know that different layers what kind, and according to that the strategies of surface mining will be done on the basis of that. Next. So we can see the different classes are there. Sometimes coal is there, it's a soft within 30 megapascal. Then beyond that it will be shell, and the hardest one is the sandstone. So one has to measure and find it out what are the layers are there inside. And this is a good graph. One can find it out that what will be the production, because we are very much associated with the productivity part of it, and what kind of production we can have, and what kind of rock types, and that will be the material removal rate. So it is started from 0 to 30, it will be coal, then bauxite, dolomite, and all those things. Limestone, it will be 30 to 50, and the productivity comes down as an exponential curves. Then you will go for those limestone where 50 to 100, and then sandstone and dolomite, and then granite where the megapascal will be increasing and the productivity also coming down. So we have to understand that. Next. So this is the cutting pick, broken pick, though it is made of tungsten carbide. It is a Swedish innovation tungsten, hard stone, heavy stone. That carbide along with the cobalt will make the front end part of it, but it is also getting damaged if the hard things are there. So we have to know what is the material, and through vibration monitoring, we will know the material, and according to that, we will do that. And this is the most consumable part of any surface miner. Next, we are, because of some good funded project from Department of Science and Technology, we are just building these cutting rig lab model so that we can just miniaturize and model and simulate the operations of a cutting drum in the different kind of surfaces to know what are the forces, what are the accelerations, this displacement, velocity, acceleration, and according to that, we find it out what can be the optimum parameters. Next, our main objective will be the vibration monitoring of the cutting drums, both at the lab and the field. We are doing it in the lab, but though the field is very big, in situ conditions are more challenging. We have different mines, and you know that we have also discovered the second largest coal mines in some part of Eastern India. So huge amount of tilted, huge amount of mining activity, especially coal mining has to be done, and with those things. And feature extraction from the captured vibration data to analyze the differentiation between coal, shale, and limestone, so that we can control those parameters related to surface miners, and according to that. And last, the fixation of the strategies for controlling operating parameters for different surfaces encountered by the surface miners, and the surface miner operator cannot understand, so that we want to do some kind of mechanical assessment associated. Next. I think I have missed out one page. Okay, so that is overall the purpose of my talk, to vibration monitoring of the surface miners, to know what are the different geological conditions, and according to that, the strategies of the running of the parameters and process control parameters of the surface miner will be controlled. Thank you.
Thank you very much for a very interesting presentation, and very complimentary to the first one. And now, please ask the questions. Okay, who is first? Oh, yes, Erkan, please.
Yes.
Maybe I can start with a question.
Please.
The level or the acceleration level in this mining machines are in which level?
I can tell you, it may be, say, the cutting drum is rotating, say, 30, 40, 60 meters per minute. Okay. And the cutting drum diameter is in the specification, it is 4-meter drum. And then we maybe say a couple of times of that. So that is the thing, and we are placing all those accelerometers in different positions in the shaft and other part of it to see the three directional, what is the vibrations, what are their peaks and A50 and what are part of it, to know extract when it is cutting coal, what is its behavior, when it is cutting sandstone, what is its behavior, and when it is cutting shale. The problem is that in the night, people are finding it out that it has encountered hard rock and so much of wear and tear takes place. So machine has no control to know that this is the thing and this is the vibration, this is the signature of the hard, so go slower and console. So that is the problem of dealing with these things, and it has whatever geological exploration you do, you cannot tell what is exactly happened whenever you are inquiring of that. So vibration can be a game changer analysis in order to operate that very costly machine. And Poland is also making such machines. I know that the operators here in Dhanbad area, a lot of people are using some of the Polish words. How do you know? Because the Polish engineers came here and installed, and many of the machines like mine winders are from Poland. Poland is a country who are very, along with the Germany, very, very strong in making big machines related to the mining applications.
Oh, okay, we are learning something new. I was not knowing. Another question, please?
Did you conduct some survey with drivers of these machines? Because they, of course,
We have some company, the NK Instruments, they are providing us the different accelerometers. We are putting those accelerometers both at the mines, but the mines are very difficult places, inaccessible places, along with our model. And we have, along with that, fabricator L&T, who are the fabricator of all those surface drums. So three-way with one instrument manufacturing, one who is surface drum manufacturing company, along with the education person. So we three are working together to find it out that the right kind of cutting drum with different kind of cutting picks to get the best performance.
Okay,
So,
and
then,
yeah.
Professor Swamidas will start.
I am presenting related to this whole body vibration. Can I start my presentation? At the end, we can
Of
have
course,
the
please,
Yes.
please go ahead.
Please.
Yes, actually, I am Kumar Swamidas, Associate Professor in IIT Dhanbad. Actually, today I am going to present a human response to vibration in heavy earth moving machineries. Actually, no, if anybody, any human being have to be a success in their life, actually, which one is important? I like to ask with the people, but because here interaction is very limited, so I like to tell the answer also. Actually, if any person have to success in their personal life or professional life, or any company success, or any industrial success, or any community how to live success, actually the health, good health is a very, very important. Actually, if someone is having a good health, he can be success in their profession, and he can be success in their personal life. Otherwise, if industry also success behind of the employees, if the employees have the good health, then only he can able to contribute to the industry. So the main focus to the human community is good health. If the good health is there, always the wealth will be good. So if we have to be a good health, the body have to be, we are every day we are exposed with a lot of activities. Each and every activity is involved with some effect on our body. So one of the effect is the whole body vibration. Actually, in our day-to-day life, by knowingly or unknowingly, we expose with the whole body vibration and hand-arm vibrations, prolonged working shift, and noise pollution. These are all the factors. These are the four important factors. We are everyone in the world exposed with these four important factors in our day-to-day life. It is exposed to our human body, and if some people are working with the industry, it is exposed, the manufacturing industries and all, the exposure of these factors will be more influencing the human body. Actually, here I shown each and every organs in our body will be exposed more in this particular range of frequencies. Actually, the whole body vibration is the factor. Actually, it is transferred. The machine vibration is transferred to the human body through the foot as well as the backrest or seat. Now, mainly here we are mainly focusing on the research related to the whole body vibration of mining equipment operators. So the mining equipment operators, the whole body vibration is transferred to the buttocks or the operator's seat or foot. These are the main source to transfer the vibration to the human body or operator. Okay, so in that x-axis vibration is through the backrest, and y-axis the vibration through the side rest, and the z-axis vibration through foot or buttocks. So for analyzing, we have the standards, the ISO 2631 Part 1 and European Union directive. So many other standards are are there to limit the whole body vibration. And similar to that, hand-arm vibration also a very, very important factors. If we are exposed with the continuous prolong of vibrations, for example, if we are writing the if we are writing more, also it influences the muscles on the hand. Similarly, if we are the jackhammer, hammer drills, and so many equipments we are using in mines and other applications too. So those are, when we are operating that also, it will expose to our hands, that will lead to the damage or some effect to our human body. That also should be avoided. That actually we have the standard ISO 5349 part 1. 49 part 1. The other influencing factors also poor driver's posture and poor design of control, making the effect of operators and visibility of the drivers. These are the other factors that influence the operator to reduce the performance of the operation. Actually, if we analyze the whole body vibration or hand-arm vibration, and if we kept that in the limit, the human body can able to accept. So if we maintain that, if we monitor continuously and if we maintain, it will increase the production, it will increase the life of the machine, it will increase the machine availability and maintenance. It will reduce the maintenance cost, and it will reduce the product cost and operating cost, and so many factors related to the development of the industry it will influence. So it is the very, very important factor to be considered if for the success of an industry. Actually, we have the facility for measuring the whole body vibration. We have the facility of seat pad accelerometer and floor seat accelerometer and human vibration analyzer. Through that, we try to measure the vibration levels, and we try to do the design modifications on the seats or operators seats suspension systems. Through that, we try to improve and maintain the vibration level that leads to the operator's comfort as well as the improve the performance of the industry. And for that, we have two standards already. I told for measuring the whole body vibrations, we have ISO 2631 part 1, and for hand-arm vibration, we have ISO 5349 part 1. These are the two standards mostly all over the world we try to follow, and some of European standards also available, and Australian standards, British standards also available. But mostly we in India we are following these standards. Actually, this is the basic fundamental evaluation of whole body vibration. Actually, in that the few terminologies are mainly used. That is the crest factor. The crest factor is the peak acceleration divided by RMS acceleration. If the crest factor level, it is more, okay, for any operations, if it is more than 9, we have to consider the vibration dose value. If the crest factor level, it is less than 9, we have to go for the RMS value. Actually, this is the time period of any particular signal, and this is the peak acceleration. Normally, the RMS acceleration is the average of all the vibration signal, the total vibration signal. But here the VDV value we used to consider mainly through the peak acceleration. Wherever what are the peak acceleration are there, we will be taking the average of the peak acceleration. That is the VDV value. The peak acceleration divided by the RMS acceleration value will give the crest factor. These are the important factors to be considered for analyzing this whole body vibration. And as per the standard, health guidance caution zone, the limited values are given for the different accelerations, this weighted acceleration value and VDV value and weighted acceleration value for ISO, European standard, and different standards. These are the values. And the whole body vibration health issues, it will create the health issues, the back pain, back injury, and muscular fatigue. These are the different effects. It will be developed due to this whole body vibration level exceeds. And this is the lumbar disc disorders happen due to these are the different lumbar disc disorders happen if we are not maintaining the whole body vibration levels. These are the hand-arm vibration due to that hand-arm vibration effect. This is the these are the effects will happen on the human body. These are the symptoms. I'll actually one case study. Actually, we are doing research related to this mining environment and mining vehicles in whole body vibration measurements that I like to present here for this one case study. Actually, this is the experimental, we are doing it in the field, and we used to consider, actually, this is the cycle of operation of the dumper. While different road condition and different environmental condition, different operators, anthropometric conditions and body condition, what will be the effect of whole body vibration on the operator, that we practically conducted the experiment. Actually, the total cycle of operations, actually the total cycle of operation of the dumper, first the loading, the material will be loaded on the dumper, and it will be with the loading condition, it will be move on the haul road, and it will be dump the material. Then during dumping, what will be the vibration exposed, and with the unloading condition, the dumper will be returned to the site to collect the material. So in that time, what is the vibration? So that different cases are classified into 4 different conditions. Material loaded ML, that represent in ML, that is a material loading condition. Then unloaded travel, then material unloaded condition, then unloaded travel. Okay, so these are the different conditions. We measured the RMS acceleration value and VDV value and thrust factors, and we try to analyze the exposure limit. And for that, we considered different age criteria of operators and years of experience of the operators, weight of the operator, and height of the operator, body mass index of the operators. And these are the different anthropomatical parameters, and these are the vehicle specifications we performed with the different combinations of experiments, and we measured what will be the vibration level, peak acceleration level in material loaded condition and loaded travel, material unloaded condition and unloaded travel. In this different situations, what will be the vibration exposure that we measured, and we analyzed those values with the graphs, vibration dose value graphs. What will be the limited value and where it is exceeding. Based on that, we modified the design of seats, and we try to reduce the vibration level. So in that way, we are doing research in this particular area. Okay, so this is the brief outline about my presentation. Any questions or any clarifications?
Okay, the presentation is now open for the questions. Please, any questions? Yes. Who is willing to ask some question? I do not see at the moment. Maybe I will start, and then okay, I see. Yes, that just maybe please, Deepak, please, Deepak.
Hello, good afternoon, everyone. Okay, so the presentation right now is wonderful, given by everyone. Okay, I want to thank you everyone for the presentation. My question particularly is like for the body vibration, what technique or are the use for understanding them? Because in these days, the neural network and other things are being used a lot. And we see the accuracy or the dependency, or what you call like, how do you depend on that? Is it reliable, or is there any other method to analyze the technique or the vibrations?
Actually, no, Deepak, able to hear? Hello?
Can you hear?
Can you hear, Deepak?
Yes, I can.
Yes, actually, no, the neural network and other techniques, AI techniques, are to optimize the design parameters to improve the vibration. Actually, for measuring, we used to have different instruments, and we have to measure through that instrument, and we can use these different techniques. Actually, we have a lot of optimization techniques, AI techniques. Through that, the measured data can be used to optimize the input parameters.
Okay, sir. Thank you.
Okay. Yes, the next question by Erkan, please.
You show very nicely, actually, in 3 axes, there are different vibration behaviors. And ESO, of course, suggests some distribution of the vibrations from 3 axes, but our experience is that this suggestion does not work very well. Do you have some ideas related to it? X, Y, Z axis vibration exposure and their
Yes,
summation.
actually, no, the Z-axis vibration mostly we have for designing the seat and mainly focusing towards the comfort of the operator. The Z-axis vibration, the vertical axis vibration, will be mostly considered, and it will give the lot of influence compared to the other axis. So the vertical axis vibration will be mostly influencing.
Thank you.
Any other question? I wanted to ask about the magnitude, because you were showing the table with the frequency affecting near to the resonant frequency of the body parts. But what about the magnitude? It is any knowledge concerning the, despite of the frequency, the magnitude, which can be dangerous?
Yes, actually, if the uneven roads and different conditions, we have to see. In some of the conditions, it will be in dangerous limit. That is the main objective to perform this whole body vibration, to understand which situations the vibration limit will be exceeding, and how to avoid that vibration exposure to the operator or machine. That is the main objective we have to.
She is wanting to know that magnitude related any suggestion is there apart from frequency.
Okay.
Yes.
Magnitude, no, by modifying the suspension design of the operator seats, and we can really modify we can reduce the vibration. Shock absorbers.
That means you are also recording the magnitude or just the frequency?
Yes, we have to control the jerk.
Now, whether you are recording the magnitude also?
Yes, we are recording the magnitudes and jerks, and based on that, we are modifying the damping effect of the suspension system. Okay,
thank you. And the one you said, the suspension system, but before you mentioned that those big vehicles, they are bought abroad. That my question is how who modifies the equipment, the seats? That if you locally modify, or you have some feedback with the producer?
Actually, we experimentally do with some modifications, and we will see locally we will do it, and then that recommendation will be given to the supplier, and they used to modify according to that, and they used to provide.
Okay, thank you. that it is also very interesting research that in general the vibration field is something which is very close to the human being, and it is really very useful for our life to have such a knowledge and just to investigate the impact. And another question? I do not see that. At that point, I would like to thank to all the presenters. That was really, really very interesting seminar. And also to the participants that now we have 27, but I was just monitoring the number that the biggest number we have 34, that I think is a very good participation, that it is just justifies that the topic which we selected is really very interesting, and I am very
It's a vibrating topic.
Yeah.
It is a vibrating topic.
Exciting. That also I am glad to know that you cooperate, and maybe in the future we will expand this cooperation. Yes, you need to know, for example, that in Poland we have some visiting professors programs. This is NAVA, that every foreign professor can apply for internship in Poland. There is the agency.
Kindly send those links, and here also 2 months, at least 2 months, any European professors from your institute can stay here with, I think it's €2,000 per month, and that will be the honorarium. So that program is also there. And apart from that, I have requested Professor Swamidas, he is the head of the Department of Mining Machinery, along with my colleagues, that whenever the new research scholars come, we will make you also the co-guide with your confirmation. That is the less bureaucratic. We don't have to take any permission from your institute or our institute only there. So that way we can start, and then we'll go for some MOU and other parts.
Yes, sure. And I will send you the link to this agency after the seminar. But
Right,
you need to know concerning the mining that our university, maybe not, but we have in Krakow, very beautiful city. This is former Academy of Metallurgy and Mining. Now they changed the name.
We have some professors from our professors have passed out from their place.
Yeah,
I visited that place, Krakow, from.
That you know the place. And applying for NAVA, you can apply for the distributed mobility part in Warsaw, part in Krakow. That is worth to know. That anyway, I don't want to take our time. It's already more than 1 hour. Again, I thank you for the big effort to prepare such a wonderful presentations. And
Thank you.